Okay, here you can see there, that is the inverse jet transform. In the previous section of the inverse jet transform, you have came to know that is the equal that is an equation from previous jet transform. You have to take jet inverse j to the power n minus 1 in both sides. After that, choosing the factors, you get this. So there is an example that we have to use this equation to find out the inverse jet transform. That means 1 by twice by j integration of gamma means a closed contour. That means the point that there is a contour point, and that will be an unit circle, that will be not will be an unit circle, whatever else. Z to the power n f z dz of z, so we will get the fn function, that means the inverse z function. So now there is an example, fz is equal to 1 minus 1 1 divided by 1 minus 0.5 z inverse minus 1. Just multiplying z in the numerator and denominator, we get this. After that, going forward, we have to use this equation as fk is equal to 1 by twice by j, that is the closed contour, and the closed integration of z divided by z minus 0.5 into z to the power k into dz by z. There the pole is z is equal to 0.5 of residue 0.5 to the power k, and after that you have to take let yz is equal to gz xz, and then you can get yk is equal to z inverse yz. Okay, now from the inversion formula you can write like that, twice by j yz zk dz, and yz means gz xz, the other things will be the same, but gz is equal to n0 to infinity gn z to the power minus n. And after that, the inverse transform looks like that. Just put the value here, and after calculating this, and take the total value here as x k minus n, then thus yk is equal to 0 to infinity gn x k minus n. So that is the thing. Now there are two type of values, causal and non-causal values, to understand the jet transform, jet transforms. That is, the for causal signals xi close to 0, for negative I, thus upper convolution summation limit is in this case equal to k. Frequency representation of a discrete time signal is obtained from its jet transform by replacing z inverse minus 1 is equal to, tends to be e to the power minus j omega t. So that is the replacing the jet transform by replacing that, and where t is the sampling period of interest. Justification will be given later. Thank you very much. That is the inverse jet transform and jet transform equations, that how you could do jet transform in real time. So thank you very much for being with me in this lecture.